Good morning or good afternoon, wherever you are. Thank you for joining us at the joint Arab States Broadcasting Union, uh, Asia Pacific Broadcasting Union, and World DAB annual DAB Plus workshop. In this workshop, we highlight a lot of the new developments, but also give you some of the existing features for discussion as well. We cover a broad range of topics. We're in day 2 today. Yesterday, we heard more about business case and recent technical developments, particularly about the new emergency warning system, which is being launched later this year. It's with ETSI at the moment for standardization, and we'll see that early next year really in product. Today, we have got a more technical program. I will just share my screen. And today, we start off with features. It's always good to revisit the feature set, especially for attendees which don't have much background in DAB and are learning about the system. We then have, that'll be presented by myself. We then have Mr. Lars-Peder Lundgren, who's the CEO of Paneda Sweden, and he will talk about DAB headend systems and the latest developments with those. Then we have a session on DAB transmission by Mr. Oscar Hugh. He's the APAC sales manager at GatesAir. And then finally, we'll have Mr. Roberto Di Bari, who's CEO of Aldena, to tell us about antenna systems for DAB deployments with a very, very interesting use case from Italy. So, and we'll close with some Q&A. Now, on the Q&A, please put your Q&A in the Q&A box at the bottom of the Zoom screen, and we will try to answer those as we go. If we have time at the end of the day, we'll also be able to have a discussion as well on some or maybe even all of the questions. However, if we don't get to your question today, we might get to it tomorrow, or we'll definitely answer it by email if we do not get to that. So all questions are valid, and we look forward to all of those. So now I will start my session. I thank all the presenters in advance, and of course we'll thank them at the end. So let's kick on to DAB features. So let's look. What we'll do is we will look at the DAB broadcast features. We'll have a receiver overview and a brief discussion on hybrid radio operation. So as you know, or you might know, DAB digital delivery is a digital delivery data system where we can host multiple services on a single transmission. Now, typically, a single ensemble, as we call it, will host between 18 and 24 services, although I have seen some up to 32 services in a single ensemble, although I would not recommend that. It just goes to show the flexibility of DAB, however. We note that each broadcaster can control their services independently and set their audio bit rate and associated parameters accordingly. We have program-associated data in the form of independent text and slideshow images, and a number of advanced features we'll talk about a bit more in the future. And of course, we also have data services. In fact, we can also deliver video if required, and that's been certainly used in places like Korea, and for some time, I'm not sure if it's used still in Norway or not, but it's certainly a feature if you wish to use it. So let's look at some of those features. The first one is there's room for lots of services. And that is by far one of the biggest advantages of DAB, certainly over FM and other similar or other digital services either. You get a lot more service availability. And here's an example from Australia with which were prior to DAB, AM and FM stations. And you can see here, for example, in Sydney, in the commercial market, there was only 12 services. Now, look at that. In Sydney, there are now around 80 services, 75 to 80 services, depending on what's on. There is always pop-up stations and stationed adjustments, and we'll look at some of those in a minute. The point is there's a lot more. And we can see the same in other places, like in the UK. This is national services in the UK. Oh, actually, no, this is from Wiltshire. This is in a county of Wiltshire, 69 stations. And that's before small-scale community radio was established. We'll hear more about that from Dr. Laurie Hallett tomorrow. So if you're interested in new ways of doing DAB+, certainly tune in tomorrow. Now, a similar situation goes with Berlin. There's now 77 stations in Berlin. 77. So this is one of those things which is quite pervasive. And we can look at some examples of how networks can expand their coverage and their number of services. Absolute Radio started out in 1993 as Virgin on AM, one service on AM. In 2008, they went to DAB in the UK, and now they have 9 DAB services on UK DAB. And that process, they've actually tripled their income. BBC have done the same. There was 5 services originally. Now you look at how many there are now. Some of those are local, sure, but if you look at the main ones, they're national. And there's always brand extension. And here's a couple of examples. We've got Heart in UK, Heart Extra, NRK in Norway, P1 and P1 Plus. And we can see from the BBC, we've got 1 and 1 Extra, 4 and 4 Extra, 5 and 5 Live Extra. Pardon me. So a lot of opportunities for stations to expand their coverage and provide alternative content. And here's another example from Australia with the HIT network and the Triple M network from Southern Cross Stereo, which have 2 FM stations, but each of those have an additional 6 DAB Plus only services, providing a whole range of different music. In this case, it's a bit of a combination of genres and decades. Just like Absolute Radio is basically mainly decade focused, with now moving into genre as well. And of course, we have room and availability and the ability to do pop-up stations. Here's a couple of old ones: Elf for Christmas, Canberra Anniversary, Olympics in London a few years ago, emergency situation in Queensland and Brisbane. This is still done, and we can see it here with just recently with Capital, Taylor's version. So that's a new station that was put up to cover Taylor Swift's Eras tour of the UK. There's another one in London called Magic Soul Summer, where they put up an additional service focusing on soul music. And also the BBC and Jazz FM got together for the London Jazz Festival to do a combined pop-up for the period of that Jazz Festival. So lots of different ideas there, and that's always good to see. I'm sure we'll see a lot of pop-up services in Paris and in France, and maybe in many other countries during the Olympics in the coming month. Okay, so, and of course, let's move on to some of the other features. We know that we can choose our service by name. Services are listed alphanumerically. No need to remember station frequencies anymore. And it's really good for brand recognition to also include logos. And we're increasingly seeing broadcasters adding their logos to their transmissions or using hybrid radio in vehicles for delivery of logos. So much easier for brand recognition. Of course, we have text, also called dynamic label segment or dynamic label segment plus, if you want to do some fancy stuff. And that delivers very effective textual information, typically things like now playing, next playing tracks, who the DJ is, what the show is, or maybe who the advertiser is, because it's very easy to synchronize the text with the audio. And here's an example of one of the newer receivers. Very nice image with this slideshow as well as the text as well. And here we go with slideshows. Very good for album art, title and artist, those sorts of things, but many other things you can do with it as well. You can deliver the weather, the latest news. You can have clips of the presenters and all manner of things. It's up to the broadcaster to be innovative. DAB has the features to deliver this. And we're now seeing more and more receivers with color screens and increasing sizes in color screens, particularly in vehicles. We'll talk more about that in a minute. There's another new form of radio. They're starting to look a lot less like old school standard traditional radios. This is much more like modern products. Let's talk about data services. Here's an example from Korea who have TPEG, traffic information. And this is an example from Seoul, their capital city, of course, with current congestion and flow. But you can also deliver a whole range of other data with that flow information. Things like fuel locations and prices, parking, even speed cameras, I'm sure, and other such things, emergency situations, roadworks, and so forth. There are other data services like Journal Line, which is a hierarchical categorized information service. And if you wish, you can even write your own custom application. You can develop your custom application and get it included in receiver products. Much easier these days. We have a number of advanced features in DAB, and I'll just go through them briefly. We have service and program information, announcements and emergency warning system, and I would advise that you can see more on the emergency warning system from day one presentations, and those presentations will be made available at the end of the series. But some very, very exciting stuff there. And of course, service following as well, which now has a new automatic safety alert logo to allow purchasers to easily identify radios with the new emergency warning system capability. Okay, receivers are now mass market. Typical prices start around $20 US, although I can find some that are even less. Over 120 million sold, and we can see the huge range of examples here. In fact, here's one here for 65 Australian. That's about 45 US. Here's some more from Australia. Cheap as $24. That's like $18 US. Cheap. So cheap products are available. They might not all have color screens, but here's one saying US $18, 5 pieces color screen. So you buy in bulk. This is for retailers. There's plenty of opportunities for cheap receivers. Lots of different types now. Here's a camping lamp with a DAB receiver in it. And here's a tradies, electricians and plumbers. Builders, they like to have tough gear. You can buy them too. There's one from Technisat. There's plenty of others around too. And of course, just about every automotive brand now supports DAB+. It's high high activity in Europe has really driven this, but that is now expanding beyond Europe into places like Saudi Arabia and Asia Pacific. Vehicles are also targeted for hybrid radio, and hybrid radio allows you to have the combination of broadcast audio through DAB transmission and all of the normal features you get, but also through broadband mobile IP or even fixed IP. You can get a number of different features as well, including logos and program information, some interactivity. Broadcasters can get metrics and analytics. You can have high resolution images, which are particularly important in cars with high resolution screens, and IP service following, and a number of other things as well. So hybrid radio is in these cars, and this is just a few of them. But these are some of the very active players: Audi, BMW, Mercedes, Mini, Seat, Porsche, many others. Ford, I probably should have put Ford on there as well. So in summary, I'll just say that digital radio provides a very wide range of advantages over traditional audio. It's more spectrally efficient, allowing many more services. It has high quality audio, which broadcasters can optimize their own audio rate versus their bit rate versus their audio quality. We have program associated data and text and images, advanced features, data services, hybrid capabilities, and a huge number of receivers from very low cost to very fancy ones if you wish. So I hope that has been a good introduction on what DAB can deliver to you. I will now stop sharing my screen, and I'm going to hand over to our first guest presenter today, which is Lars-Peder Lundgren, CEO of Paneda. So please, LP, over to you now, and to present your presentation. Thank you very much.
Thank you, Les. My name is Lars-Peder Lundgren from Paneda. We are active in different business areas, but mainly we do DAB headend systems. And me, myself, I have been working with DAB since 1997, so almost from the very beginning of DAB. Again, we are active in 3 business areas. We do the TV networks in Norway, and we do the radio break-in systems for road tunnels. And our main focus is to provide DAB headend systems, multiplexer, audio encoders, and those kind of things called DAB headend system. And we are the leading supplier. We have over 200 systems in operation worldwide. Even though we are a world-leading company, we are still a small company. We are only 22 persons. We have 6 dedicated developers and a strong DAB focus. And we develop both hardware and software solutions. And we try to keep up to the latest DAB standards in whatever we do. And we are also experts in virtual solutions such as VMware, also Docker containers. And of course, we are a member of WorldDAB and is quality certified against ISO 9001. Our systems is spread across the world. We have a lot of premium reference customers, Arkiva in UK, for example, which operates 62 DAB multiplexers with nearly 400 radio stations on that platform. And that's the biggest platform, DAB platform in the world. We also have customers in Australia, ABC and SBS is using our platform, and Belgium, France, etc. So we are represented in most countries around the world. The topics today is to say a few words about the latest development, virtualization, for example, and also a few words about the language signaling for Arabic and for Asian languages, for example, and also a few words about metadata, how to integrate now playing, next song, nice content in general. Most DAB multiplexer systems today are provided as a software solutions today. And these software solutions are also capable to be virtualized. And software solutions mostly offers most benefits and flexibility, where you can put many multiplexer systems in the same hardware, and you are not hit by any hardware limitations. It's just the server performance that sets the limitations. Software solution can also offer quite high IT security with modern encryption technologies, for example, and it's very cost efficient. Another nice thing with the virtualized solution is that it's very, very scalable. You can start a new multiplexer system whenever you need. You can just scale up and without any hardware investments. And it's also flexible, of course. And in a software solution, it's easier to develop new feature, which means that we can have a very fast time to the market with new features. And as you heard yesterday, and also today and tomorrow, the DAB standard is quite dynamic. We add new features in the DAB standard all the time, and we can easily adopt that in our system and release it to the market. And it's also a strength that we can use generic hardwares like hardware from HP or Dell. It's good for spare parts, replacements, and also, of course, support and maintenance. All right. The system today is based on that we have the hardware ourselves, and on top of that, we install the hypervisor. Up to date, it's VMware has been in the most used hypervisor. So on top of the hardware, we install VMware, and then we install the multiplexer system as virtual machines, where each machine or virtual machine is running its own operating system and the software for the DAB multiplexing. So that's the principle. We install the hypervisor on the hardware, and then we create virtual machines on top of that. The latest development is that we move away a little bit from VMware, for example. You probably heard that VMware has been acquired by another huge American company and not offering VMware for free anymore. And in fact, it has been quite expensive. You need a subscription fee. You need to pay for VMware. So the latest trend is that we are moving away from hypervisors and instead focus on what we call Docker containers. It's similar, but with a little bit different approach. It's based on the principle that we only have one operating system. So on the hardware, on the bare metal, we install the operating system, which of course is Linux based. And that operating system is host for containers, where each container is an isolated environment on top of the operating system, where you create multiplexer systems. And this way is much more efficient. In fact, it's 50% less performance overhead. Means that you can fit more multiplexers on a cheaper hardware, on a cheaper server. And it's also easier for maintenance. It's so easy to create a new container with it, for example, for upgrade reasons, where you can just spin up a new container with a new version. You can run two versions in parallel. You can have one for test and one for production. It's so flexible. And you don't need a hypervisor in between. It also means that you don't need any updates of the hypervisor security patches, for example. Here we only have one operating system for the complete platform, and they are sharing that operating system. So again, you have the server. We install the Linux operating system, which is Docker container capable, and we create containers. And each container is an isolated environment containing multiplexer and encoder systems. Again, 50% less overhead, very secure, and very flexible, scalable, and easy maintenance. Once you have the hardware and the Linux with Docker installed, you have what we call the orchestration interface. that's where you set up your platform. And it's actually basically only 3 quick steps. One is that you define your networks, how you want to separate the data traffic. For example, you may need audio on a separate network. You want the distribution, the EDI output from the platform on one isolated network, and one for remote access, internal management, monitoring, whatever. So that's the first step. You create your networks for the complete platform. And second step is that you create multiplexers, containers on the platform, and then you just click start. And then you're ready to go. In the orchestration interface, you also do the upgrades and maintenance. You do backup and restore of the complete platform. And you can also monitoring the platform, the hardware resources and those kind of things. CPU load, memory use, network bandwidth, all these kind of things are done via the orchestration interface. So once you have clicked the play button in the orchestration interface, you can start configure your multiplexer. And that is done in a separate user interface. So once you have clicked start, you will reach the multiplexer user interface where you can start adding your radio stations in a user-friendly way, of course. You just need to set up audio inputs and the outputs for the transmission part. Not complicated at all. Next topic to talk about is the language support. One issue today is that the service label in DAB can be a maximum 16 characters. That's what we call the long label. And we also have something we call short label for services, and that's maximum 8 characters. EBU Latin 1 and UTF is the 2 formats supported to use. The problem is that many languages uses 2 bytes per character, most Asian languages, for example. And that would limit the label length to only 8 for the long one and 4 characters for the short one. And another problem is that if you use UTF, you will disqualify many receivers. There are really lack of support of UTF because most receivers are handling only EBU Latin 1. So you may end up with a question mark as a station name. Doesn't look very nice. And it was mentioned yesterday that the DAB standard has been updated, TS 101756. It was described yesterday. But the principle is that we can now support 2 labels. One standard label in the EBU Latin 1 format, and you add another one called extended label, which has get rid of the length limitation and can use UTF and UCS. So the idea is that a receiver that is not compatible to this new standard, it will read the normal label. And a compatible receiver supporting the latest standard can read the extended label with your local language. Regardless, in red, I highlighted this. It's a requirement that manufacturers need to be aware of. They need to know this requirement. And for example, I know that Thailand has drawn up a specification that will apply to all the imports of DAB radios into Thailand, that they need to comply to this new standard. So I think that's a big thing to remember when you start with DAB. Make sure that the receivers are supporting your language. In our system, it's not complicated at all. In the web interface, you create your station name in standard label and extended label. That's it. And then you are broadcasting 2 labels. So you make sure that you are compatible to most receivers, at least not having these question marks. Next topic, let's talk about metadata. Les talked about that earlier, but it's really a feature that everyone should use. It's an improved user experience. It looks so much better. And it's really one of the core things that a new listener will actually notice when he switches comparing to FM. We talk about text services, about picture, slideshow pictures. And there are different ways to manage the content, of course. On the screen, we have 3 different examples, how you present your graphics, but you can be creative. And it's also a powerful tool for advertising. To integrate your metadata into DAB, it's normally not complicated at all. Normally you have a playout system, and the playout system hosts the information, artist, song, program information, and maybe also all the pictures in a database. You just need to send this over to the DAB platform over an API, application programmer interface, which is basically just a simple web-based command to the platform. Or there's third-party software that can sit in the middle, like a middleware, and that content system talks to your playout system and grab the information and send it over to the DAB platform. But in most cases, you have a playout system that hosts the information, so you have that information already, pictures and everything. You just need to do a live export over an API into the DAB multiplexer system. It's normally zero complicated. One thing is how to synchronize the metadata, especially the pictures. We have something called transfer time after the DAB and in the transmission network until it's shown up in the receivers. And that transfer time depends on the bitrate you have allocated for the data services. But it's very common that a picture takes at least 15 to 30 seconds. That's quite common. And that creates a problem. How do you synchronize that picture with what's on air? So you can end up in a situation where, as you can see on the screen, where Queen is playing a song while you have an artist picture of ABBA instead. You have a mismatch. And there are many creative solutions to overcome that. And the standard also allows some signaling called trigger time. So you actually send a trigger when the picture should show up on the receiver. It turned out that very few receivers care about trigger times. They show the picture as soon as they arrive, and you will end up in this problem. You can delay the picture, of course, and wait a little bit, but you can be creative. But it's really a question that many radio stations ask me all the time. We have developed, I think it's clever, a clever way to at least based on the principle that you can send the picture to the platform, to the Paneda multiplexer platform, and we broadcast 99% of the picture. So we keep 1% of the picture in the cache memory. It means that on air, the picture is 99% completed, but not 100%. So it means that in the receiver's holding buffer, it will be cached. And the player system can then, when the music starts, just give the Paneda multiplexer command, send the last byte, and we will broadcast the last byte, and it will be perfectly synchronized with the audio. So you can really synchronize when the song starts, the text and the pictures, and it's quite easy to implement. A few words about station logos, just telling that I think that's very important. It's a really nice DAB feature where you, in the channel list or a station list, see the station logos instead of pure text. It looks so much better. And it's so easy to add in the system. You just drag and drop your station logos into the web interface, and there you are. To do all this fancy stuff, you of course you need a system with a well-defined API, so you know how to integrate your playout system, and you need an API that is well documented and web-based and easy to integrate. And Paneda, for example, we are following the Open API version 3 standard, which is a clearly defined standard for how you do your API commands. And it's really essential. I will not to save time, I think I will just stop here, but the Paneda API is well documented. It's actually online as well and dynamically updated for every version. That's all from me. Thank you.
Thank you, LP. A number of very interesting developments there, particularly like the Docker containerization and the simplicity that it brings to ensemble, multiplexer installations, which we see regularly around the world. And very, very pleased to see your, what I think is a clever implementation to overcome that synchronization issue that we see around the world. I know I'm very frustrated in my country that I'm seeing the album art from the previous song, not the current song. And that's a very, very clever way to overcome that. And I hope you get very good traction with your features on the Paneda system due to that that innovation you have done. Okay, we're going to move now to RF land. We've got two presentations coming. The first one is on transmitters by Oscar Hugh from GatesAir, and he's going to particularly tell us about multi-ensemble transmission. This is a really, really sensational way of reducing the cost of your transmitters when you have multiple ensembles from a single site. So, Oscar, please, over to you. Please share your screen, and I look forward to your presentation. Thank you.
Okay, welcome everyone, and thanks Lex for the introduction. I'm Oscar Wu, and I'm the regional sales manager for GatesAir for the last 5 years. And today we are going to talk about how to improve and save more in the transmission of the DAB system. As we know, in the last 20-30 years, the technology of the transmission make very big steps. Yesterday, with Lundgren said that the efficiency for the transmission was increased 4 times from the first transmission in BBC. Now, today, we are showing how we can reduce almost 4 times more the costing to have the transmitter system without changing much on the transmission station. But okay, if you have any question, please write in the Q&A box and I will reply after the presentation. Okay, Gates was established more than 100 years ago in US Quincy, and we have more than 100 years of experience on developing and manufacturing transmitter system. We are always thinking how we can improve and make better solution that can help the broadcaster to have the best solution at the minimum cost. Before going in depth on the main topics on of the multi-carrier DAB transmitter system, I want to introduce to everyone what is the traditional transmitter station setup. So the transmitter station is not just the transmitter itself. Usually it's composed by many items. For example, we can consider the patch panel or dummy load, the feeder cable, the tower, the antenna, but it's not only that one. It's important, for example, the AC power input for the transmitter that is consists, for example, for transformer isolator, AVR, UPS, grounding system, lighting system protection, and every other things that need for the transmission station. In addition, the very important factor is the cooling for the transmitter station. All the equipment are generating heat, and even if nowadays transmitters are very efficient, but still generate heat in the transmitter room that need to cool down. Nowadays, the average efficiency of the transmitter is around 40%. This means if we transmit 10 kilowatt or 1 kilowatt DAB, the total power consumption and the heat is going to the room is around almost 2 kilowatt. 2 kilowatt in terms of BTU is around 10 kilowatt BTU. So when we talk about the cost of the transmitter system and station, first we need to consider the space and the building or the place where you need to rent. In a big city, sometimes they have the transmitter station directly in the tower of the city, and sometimes it's very expensive. So have more transmitter in one room sometimes is impossible. And this solution to have the multi-DAB transmitter is a possible solution that can solve this problem. Then we need to consider also the maintenance cost. So have only one system that need to maintain, reduce a lot the cost. And then we're talking about the electricity cost and the manpower for the management and control of the station, and then all the other factors. In the multi-DAB transmitter system, we maintain the same cost to have one transmitter, but in this case, we are transmitting for a multiplex or for ensemble. So we still have one antenna, one feeder cable, one dummy load. Okay. And the only difference is we receiving different ensemble directly on the transmitter. So now we are going to explain a bit better how is working and in which way the multi-DAB. GatesAir is developing in the last few years a new transmitter for low and medium power, and we are the only one that is able to transmit 4 ensemble in one transmitter. We are using the technology called common amplification, that after the generating in our engine the 4 baseband signal, we multiplex and we upconvert in RF. Then we apply a new algorithm for the pre-correction of the broadband linearity to have always a good quality in terms of signal quality and MER. This is a very big technical and economical advantage because we don't need to have 4 transmitter and also no need anymore to have a traditional DAB combiner. But still we need to have a bandpass filter for the DAB bandwidth. This solution can help also to have low maintenance cost. Okay, we have 2 possible solutions or products for the multi-carrier DAB. One is for the compact transmitter that can power up to 750 watts. This means exciter and power amplifier is in one box. The second solution is the exciter and amplifier in a different box, and in this solution can reach up to 1.9 kilowatt. But how we can have 4 ensemble in one system? So we need at least have 4 input. The exciter for this solution have a different option, and by default we have the 2 ADI or 2 ATI input, or with the board we can have 4 ATI. We have also an optional to receive from satellite and extract the DAB signal to be transmit, or we can also receive RF and retransmit like the gap filler. The amplifier system use RF transistor in VHF band 3 Doherty that have efficiency of more than 50%. But if we're talking about the system efficiency, including exciter, fan, and all the other components and equipments in the transmitter system, so we can reach more than 40% the efficiency of the transmitter itself. Back to the topic of the power, suppose the total power output of the transmitter is 1.9 kilowatt, and this power is shared to all the different ensemble. Suppose we have 4 ensemble, then the power for each multiplex is 475 watts. In case we consider also the gain of the antenna system, then this means from 475 watts, we can reach up to 1.9 kilowatt ERP power for each ensemble. And in this case, we are transmitting 4 ensemble from 1 transmitter. As discussed, the main advantage are the system is more economical than the standard solution. Only one system and we can transmit 4 signal. Then the system use less space and is more compact compared the traditional transmitter. So in case we need to transmit 4 multiplex, we need 4 transmitter. And if the space is one of the constraints, this should be the best solution. The consequence of it is to have less operational cost, OPEX cost, and the total power consumption of the transmitter station is less than have the 4 transmitter system. Then with the new algorithm of the pre-correction, we can still have a very good performance in terms of signal quality and MER. The system can also work in SFN. So for this one, for each ensemble. For this one, we need to install in the transmitter the GPS with the GPS antenna for the synchronization. In this slide is show the 4 DAB channel. In this case are adjacent, but also we can see different configuration. Like in this slide, the first screenshot show that the 2 channel can be not adjacent. In our solution, the distance between the first and the last DAB carrier is of 8 channels. For the 4 DAB, we can also have the configuration with 2, 3, or 3 in a different space. So it doesn't mean that all the channels need to be adjacent, and we don't make any constraint in the position of the channel. The last screenshot in the bottom is show that the MER of each signal is still quite good. We are talking about 38 dB of MER. Even if the combination is inside everything is digital and there is not internal intermodulation. So how the transmitter is looking? As to before, we have for the compact solution 3 types. So 1 RU size, 2 RU size, and 3 RU size. Here is the compact solution with 1 RU size that can transmit up to 150 watts DAB, share between the different ensemble. And from the front view, we have the possibility to have the 2 input board. One is for the satellite and the ref. The second one is for the ADI and ATI, or only ATI. Then we have all the control with the keyboard, display, and the Ethernet for the remote management. Then from the rear of the transmitter, we have all the signal for the synchronization, the SFN GPS, all the signal for the pre-correction and the RF output, and then the input power supply. Then for the solution with 2 RU can reach the power up to 240 watts total power. The concept is the same as the 1 RU, is just we have more RF pallet and more power for this solution. And the third one, compact solution, is the 3 RU with 750 watts. Then we have the multi-carrier that can use one single or dual exciter to have a minimum of redundancy. For this solution, the maximum power can reach up to 1.9 kilowatt DAB. The system also don't need to have any control unit. So the transmitter with a dual exciter is can be proposed with the exciter and amplified without any additional equipments. So there is not control unit for the redundancy, and the system is high efficiency. For the solution with the external amplifier, we also have additional redundancy system for the power supply. This means power supply is always active and the third one is in backup. So if one of the power supply will be failed, the system is still working 100% of the power. The problem of is not a problem, but the weakness of the multi-D is if the transmitter will be fail, then all the four ensemble will be down. So usually we suggest or advise to use the N+1 or 1+1 system or configuration. So we have some equipment that allow to create the configuration to transmit in a safe mode. Here is an example. We have the main transmitter that is transmitting, then is connected to the automatic changeover. So in case anything happen in the main transmitter, then the changeover will be understand when they need to switch on the spare system. So in this way, we have only the two transmitter, one changeover, and the bandpass filter or all the other equipment is only need one. Okay, we were talking at the beginning that is not needed a traditional RF combiner, but still need a special bandpass filter. So this bandpass filter is designed to make pass the 4 frequency and remove all the other frequency. Also in our system is integrated the low pass filter, so all the high frequency will be removed from the transmissions. So a bit of system comparison between the multi-DAB and the standard solution. If we need to transmit 4 carrier, in the multi-DAB system, we have only 1 transmitter, and in the standard solution, we need 4 transmitter. This means more space, and also the initial capex cost is much more higher. In terms of space, the multi-carrier DAB consider the low power is just 1 RU. And in case we need the solution with 4, then we need 4 unit or more. Then for both solution, we have the input is independent ATI or ADI is going directly to the transmitter. But in the multi-DAB, all the 4 signal is going directly to the exciter, while for the standard solution is 1 by 1. For the multi-carrier, as I told before, we don't need the RF DAB combiner, but in the standard solution, we still need. And sometimes the combiner is can cost quite a lot. For the multi-carriers, but still present the bandpass filter, DAB bandpass filter, and also in the standard solution. For the power in case we consider the 1.9 kilowatt for the DAB multi-carrier. So for each channel, the total output power is 475 watts, while for the standard solution, we need to have that power for each transmitter. And if we're talking about efficiency of the transmitter system, sure is much more better the multi-carrier DAB compared the standard solution. So what is in the summary, the advantage of the multi-DAB? One transmitter to transmit up to 4 ensemble. We still have a very good MER for the DAB application that we saw is more than 38 dB. The ensemble that we can transmit can be also not adjacent and can span over 8 DAB channel. We don't need the RF power combiner, and to calculate the power for each ensemble is we need to take the maximum output power for the transmitter divided by the number of the ensemble. So another advantage is less space occupation in the transmitter room, and this means less we save in operational cost and save in the initial cost to acquire the system or to make the setup of the system, so the capex costs. And another advantage is less maintenance for the site. But what is the limitation for the actual solution? The maximum power is 1.9 kilowatt shared between all the ensemble. All the ensemble has the same power. And we are not covering the full DAB band. I don't say about the transmitter, but I say also about the bandpass filter. Then there is the limitation on the redundancy compared to the traditional system. So this is the reason we propose 1+1 solution or N+1 solution. Our future development for the multi-D depend also by the market. Thinking to increase the power for using more than one amplifier, so to have a power more than 1.9 kilowatt, to be able to set different power for each ensemble, and then maybe to increase to the full VHF band 3 band. Thank you.
Thank you, Oscar. That's a very interesting presentation. I think this is the way of the future. Frankly, I'm a bit surprised it's taken this long to get the signal processing right to do this.
Yeah.
But there's still obviously a number of challenges in terms of the bandwidth you can cover and the power you can produce due to things like intermodulation limits and things like that, no doubt.
Yeah.
Okay, let's jump straight on to the next part, which is going from transmitter to antenna systems. We have Roberto Di Bari, CEO of Aldena, to give us some information about what antenna systems you can use in DAB, and a very interesting case study on how antenna systems can be designed to overcome interference. So I'll hand over to you, Roberto. Please share your screen. I look forward to your presentation. Thank you.
So, good morning, colleagues, or good afternoon, whatever you are, because I don't know. I see there are a lot of people all around the world. And so, first of all, thanks to WorldDAB and Asia Pacific Broadcasting Union and Arab States Broadcasting Union for the organization of this event. And thanks all of you to being here. Today, I will give you a presentation about DAB network planning with a particular focus on interference and self-interference and how you can avoid or manage them. Those are problems that you will certainly encounter during the planning of your DAB network, SFN network. Okay, but first of all, let me quickly introduce you Aldena. We were born in 1979, and since then our presence has grown daily. Nowadays, we are one of the oldest antenna manufacturers in the world. We have the largest broadcasting antenna test plant in Europe, and thanks to our hands-on activity, we gained great experience, especially in the radio and television market. Today, our products have spread worldwide, and we have a very large customer reference. Many antennas pattern and network, digital network around the world has been designed with our MLab software tools. Regarding the software, speaking about software, in 1984, we launched the first DOS-based antenna pattern design software. And in 1993, we launched the SR4Win, the antenna pattern design software, Windows-based. Over the years, this software has been updated with several new functionalities and capability under the name of SR Lite and after SR4. In 1999, we launched the NFA Pro. Is a software for antennas and near-field analysis. This software has also been developed over the years to comply with the rules defined by different countries and with several new functionalities. Its name changed to NFA 2K and then NFA 3D. Besides these tools, over the years, we have developed and designed other tools like software for digital mapping, tower locator, transmitting site management, and so on. In all this software in 2006 have merged into a single software tool, into a single platform, working platform. The name is MLab. MLab, as you can see in the slide here below, you can design with MLab antenna patterns, digital radio network, and of course perform near-field analysis for the ELM health safety. But okay, let's see how the radio coverage paradigms change over the years. Initially, the only interesting achievement was to cover the widest possible area. But then, beside having the widest area, we also wanted a stronger signal, and for sure, stronger to any competitors. And with this, a fight between the operators began to spread. With that came the necessity to coordinate with other radio stations or countries that were operating on the same or closer frequency. As you can understand, this is not an easy task. With operational cost reduction, that is an evergreen topic, lately, because of the higher energy price, the challenge is to keep the widest coverage area by minimizing energy consumption. This is how the radio FM coverage paradigms have changed over the year. Luckily, digital technology, DAB, give us a big help in solving the chaos that I just described. First of all, let me say that the coverage needs for the DAB are the same for FM. So maximize the coverage area, provide a good signal, avoid interference with other radio stations, and operational cost reduction, especially the one related to the energy consumption. I will not spending time telling you how many advantages the DAB technology will provide you, since many people in the WorldDAB organization may explain better than me, or you may also refer to the huge bibliography available. But let me just highlight one important advantage of the DAB. With the DAB, the field strength signals to get a good service is much more lower than the FM. This means that you can use less transmitting power and or fewer transmitting stations. And so how you can see, how you can understand, this is a good way to reduce energy consumption and operational cost too. As I said, DAB offers many advantages and solve many problems, but there is one aspect to consider that was not present in the FM radio transmission. I'm referring to the self-interference. So, first of all, let's see what is an interference and how we deal with it. The definition of a radio frequency interference is the presence of an unwanted or electrical energy that negatively impact a radio communication system. The cause of this interference include external and natural sources like thunderstorm or static electricity and so on, but also as well human and man-made source like out-of-band transmission, cabling, and the proximity of adjacent network operating on overlapping or closer frequency. It is the latter that interests us. We will talk about the unwanted overlapping frequency. Here you will see two radio stations, the blue one and the green one, where the red lines represent the radiation pattern of each station. This is just a simple example. The gray area represents an interference region where the station 1 interferes with the station 2 and create a shadow area where the reception of the signal is poor or maybe completely absent. Or in some circumstance, the received signals is the one from the station 1 and not the one from the station 2, the wanted one. So this is the problem. How we can solve this problem? The most used way to avoid interference is to reduce the effective radiated power, the ERP, of the interfered station. Of course, it will be better not to reduce the ERP anywhere, but only in the area where we got the interference, where the interference exists. I strongly recommend you using a professional and skilled consultant, RF planner or designer to approach this problem, because there are several ways to solve this type of interference by reducing the ERP only in one specific direction. And I am referring to the advanced antenna pattern design, because you may change the type of antenna, but this is not always possible due to the mechanical constraint of the tower. And this could be even complicated and is a costly way to solve the problem. You may also change the type of the antenna, but even this could be expensive, but with one advantage, that sometimes some type of antenna will easily allow you to design different radiation pattern. And in some case, changing the type of antenna is a mandatory. You can also change the feeding phase and feeding amplitude to each element composing the antenna. But often it's necessary to adopt all these solutions to eliminate the interference without losing the unnecessary service area. This is the key point. We must eliminate the interference without reducing our radio coverage. So these are some really basic examples of how it is possible to design different antenna horizontal radiation pattern. There are other methods. By changing the type of antenna and number of the antenna, their position, their relative position between each other, their feeding phase and feeding amplitude, you can get almost any desired radiation pattern. These are just few examples of how we can manage the radiation pattern. So let's go a little bit in detail about self-interference. In single frequency network, the transmitter are required to irradiate the same OFDM symbol at the same time. This comes from the fact that the echoes generated by the co-channel transmitter should be confined within a specific time windows. This time windows is called guard interval. I mean, outside the guard interval, part of the echo's power is associated to the same OFDM symbol as the primary one, and which therefore contributes to positively contributes to the total useful signal power, to rebuild the frame of the signal. Differently, another part of the echo's power is associated to the previous or to the subsequent OFDM symbol. And this produces inter-symbol interference, and we call this self-interference. The figures in the slide show the splitting of a generic signal power into useful and interfering components, where delta is the guard interval length. The guard interval is expressed in microseconds, and consequently, we can convert it into a space distance in kilometers. And this datum is really useful for the network planning. The OFDM receiver has to set up a time windows during which it samples the on-air OFDM signal. When the received signal are within the guard interval period or outside the guard interval period, but with the proper protection ratio, then the sum of these received signals will be constructive because they constitute the same OFDM symbol. Otherwise, they will produce the self-interference. So it is necessary to plan the radiated power and the optimization of static delays on the transmitting side to improve the SFN performance, as well to provide management to eliminate potential interference problem. let me show you a real case. This is a real case, the Campania region here in Italy with nearly 6 million population. There are 3 different SFN DAB network for the entire regions. The target is to guarantee a field strength of a minimum 6 dB microvolt per meter or even higher in some urban areas. But there are other national and international, regional and national networks operating in closer regions and neighbor countries. And for this network, we have had to avoid any interference. So the scenario is the signal propagation is in this area is very varied due to the presence of mountain. There is the Vesuvio volcano, island, cliff, warm sea, with different signal propagation to the ground. Rural, suburban, urban, and dense urban area. Area with high tourist presence during the spring or the summer season. Coastal road over cliffs, where giving radio service is important, but it's really difficult. So this is the scenario. These were the result with using some of the transmitting site already in use for the FM network, radio network. We use the same antenna radiation pattern, not the same antenna, but the same radiation pattern, but with lower gain and lower transmitting power. You can see 4.3 kilowatt is the sum of the power of all DAB transmitter, all the 23 transmitter in the 23 site. And so the 83 kilowatt, which is the sum of the ERP of all DAB antennas in these 23 sites. I remind you the ERP power, ERP is effective radiated power, is the transmitted power less the losses due to the combiner, filter, patch panel, feed line, and then multiply by the antenna gain. The results have been that we can guarantee DAB coverage for about 4 million people, which means about 70% of the population, but we create national and international DAB interference with other stations. So we conducted some optimization, and after a deep study and design, we obtained this. What this fancy color means. The red color is where we can guarantee minimum 62 dB microvolt per meter, in some cases much more than that value. And this is the service area obtained after the DAB network optimization. Let's see some number. So the result. We keep the same number of transmitters, 23 sites, but we reduce the ERP. Do you remember the DRP was nearly 83 kilowatt, and now is less than 30 kilowatt. The ERP has been reduced not only by reducing the transmitting power, but mainly by modifying the antenna radiation patterns. And then we have properly synchronized each transmitter. I mean, we have defined the delay of each transmitter in order to avoid any interference, self-interference. So the server population with DAB has been increased from nearly 4 million up to almost 5 million, which means about close to 90% of the population. But moreover, we have eliminated the interference with other national or international networks. So these are some examples of the horizontal radiation pattern optimizations adopted for the DAB in the Campania regions. The antenna pattern design can be done because it's necessary to increase the RP in some specific areas. So the field strength needs to be concentrated in some specific area or direction, because we want to spread the energy only in the area where our listeners are and not elsewhere. Another reasons to create to design specific horizontal radiation pattern is to create nulls in some direction. And you can see here on the right, we have designed a spatial radiation pattern in order to eliminate the interference in some specific directions. The pattern optimization can be done not only on the horizontal radiation, but also on the vertical radiation pattern obtained by the antenna by create nulls on the horizon that give you protection on the distance. This is the typical scenario of the interference between networks in different countries. Interference network between different countries, and simultaneously we increase the field strength in desired area. Again, these are some example of vertical radiation pattern adopted in the Campania region. So, just in conclusion, a good network design must avoid any interference with others network, with other radio stations, and can, or better, must increase the quality of your services by reducing operational cost. So the scenario evolves, and so you have to be ready to adopt your network, your solution to the new scenario. So it's really important to revise the project, to monitoring how your services is performing. So monitoring is really important. This is almost all for me. So thank all of you for your attention and being here. And feel free to contact me with any question you may have. And thank you again.
Thank you very much, Roberto. A very interesting presentation indeed. This is a typical situation we see in many countries, and the example of resolving that through antenna patterns, both HRP and VRP, is a common occurrence. I'm not saying it's easy. It's actually quite complicated. In fact, we have a couple of minutes for a few questions, so I'm going to kick it off with one of my own. And Roberto, in that example in Campania, how many of the transmissions did you need to adjust to get that the amount of improvement? Because it's very good improvement. You know, maybe as a percentage.
No. You mean adjust in terms of delay of transmitter or radiation pattern of the antenna? Because there are two ways.
I understand. I suppose, you know, firstly, actually changing the antenna, because that's the expensive option. And secondly, you know, the actual tuning of the delay, that's the cheap option. So
Yeah,
you probably have to
tuning
tune the
the-
delay on virtually all of the systems. But how many antenna systems did you have to change?
Tuning the delay, it's yes, for sure, is the cheapest solutions. But often we will not give you the results in terms of interference with other radio stations. So I don't remember exactly, but I think we have just adjust the delay on 3 or 5 site on the transmitter, and we have made antenna pattern design almost in all the antenna. I mean 20 antenna respect the 23, but we were lucky because in that case the antenna was not an existing antenna, it was a new antenna. So when we started from scratch, and then we can design any type of radiation pattern that we want. We have started from the radiation pattern user for the FM, and that was the you know, it's starting from then, but then we have to design a new pattern with new antenna, but we were lucky because the antenna was not present at that time in the transmitting site. It was completely new, so it was not an additional cost to design the antennas.
Okay, excellent. I see there's a number of Q&A questions have already been submitted and answered. There's one here though that hasn't been answered yet, and that's again to you, Roberto, and it is from Badruddin Kusa. Is it possible to use analog TV antenna VHF band for DAB transmission? What would you say to that question? How would you answer that?
Yeah, I'm not lucky, but yes, because, you know, we are antenna manufacturer, we sell antenna, but yes, you can use them if the radiation pattern from that antenna is suitable with your design. And don't forget the typical polarization for TV band 3 antenna was horizontal, while the antenna for the DAB needs to be vertical. But if your antenna is vertical polarized and the radiation pattern meets or will not create any problems to your network, then yes, of course, you can still use the existing antenna. Absolutely, yes.
Yeah, okay. I agree with that. I would put one caveat on it, I suppose. And I see this in field trials. It's often used that use a horizontal, you know, an old analog TV antenna for a DAB trial in horizontal polarization mode. While that is not ideal, it will give you the ability to actually test. But, you know, ideally it should be a vertical polarization on the antenna. Now, it is also possible to actually take that panel, those antenna panels, and rotate them through 90 degrees to get them to be vertically polarized. But it does take a bit of effort. I think that effort would be paid off in terms of the ability to map between measurements and predictions. So, well, it's useful. It's better if you can do vertically polarized solutions.
No, absolutely. I'm agree with you. It's useful. You can use it for trial test. Absolutely. Don't spend your money. Again, you are killing me, but don't spend your money for a new antenna if you got something. But then it's better if you go in vertical. Keep in mind that Yes, you can rotate your antenna 90 degrees. So from vertical, you will put it in, from horizontal, you will put it in vertical, but it's depend about the type of the antenna. Some antenna, many antennas got some holes on the antenna to drain some humidity and so on from inside the antenna, so draining the water. When you rotate, it's become that they will be a fantastic point where the water go inside of the antenna. And then you can have a big trouble. So in line of principle, yes, it depends about the antennas if you rotate. Again, please use your consultant to check if this is possible, it makes sense or not. But yes, in line of principle, just rotate on 90 degrees of the antenna. In some case, we already done it in the past. Yes, of course.
Yeah, I agree. It's not ideal, but for a quick field test or something like that, it might be a solution. Obviously, a new antenna would be a better option, even if it's just in a few bays of dipoles. That's often all that's needed to do initial field testing when you're starting to adopt DAB. All right, thank you very much for that, Roberto. Look, we're just over time now. We've done very well. Thank you to all the presenters today, to Roberto, to LP, to Oscar, for being right on time. Fantastic effort, fantastic content. And thank you, audience, as well. We had very good participation again today. I think the peak was almost 150. I think it's 146. So lots of interest, and that's fantastic. There's been a number of email addresses and websites and so forth. So if there are questions further, please contact us. We will attempt to answer the unanswered questions. The ones weren't answered live, most were. So well done to the presenters on that. But we'll do our best to answer any others. Now, remember, tomorrow we have day 3. Tomorrow is about all getting on with it. And we have presentations on the automotive status. We have presentations from Africa, from the Asia Pacific, from the Arab states on how things are moving forward. And hopefully we'll have time for a panel session at the end talking about how to move forward through planning your DAB networks. So with that, I think I will sign off and say thank you very much again. And hopefully we'll see you all tomorrow. So thanks, everyone. See you tomorrow.